Impact analysis. Now let's proceed with sensitivity analysis. Now, just a quick recap. We are discussing about sensitivity analysis, and you see that these are one of the project evaluation technique or risk evaluation techniques, which identifies the key factors affecting profitability. Then each factor is analyzed at time, or they are subjected to adverse condition and isolation. And they say that sensitivity can be carried in two perspectives. One was the break-even analysis, the other one was impact analysis. What do you say about the break-even analysis? So that at break-even, NPV is equals to 0. Therefore, present value of cash inflow will be equal to the present value of cash outflow. Then another thing we said about the break-even analysis, we compute the percentage change in each variable, percentage change in each variable. Then we see that the smaller the percentage change, the more sensitive the variable is and vice versa, right? Good. So now let's look at the other perspective, impact analysis, impact analysis. Right to see that? Under this method, we compute the percentage changes, compute the percentage changes in NPV, percentage changes in NPV when variables are affected adversely, when variables are affected adversely, when variables are affected adversely. Good. Can you underline percentage change in NPV? Underline percentage change in NPV. As well as also underline affected adversary, affected adversary. I remember you say that when variables are affected adversely, that means negatively. If cost is affected adversely, they increase. If revenue are affected adversely, they reduce. Good. Now let's do an illustration. December 2013, question 2A. December 2013, question 3A. Sorry, question 2A, not 3A, question 2A. We did that question. R Limited is considering a project with the following cash flows. That's 2A. So we have the 2 years, we have the cost of the plant, running cost, then we have savings. R Limited cost of capital is 9% required. Determine the sensitivity of the variables to changes in the level of cost of plant, running cost, and saving, considering each factor at a time and assuming each factor is varied adversely by 10%. Read that required again, that determine the sensitivity of the project to changes in levels of cost of plant, running cost, and saving, considering each factor at a time and assuming each variable is varied adversely by 10%. So write NB, just write it in your notes, NB. The higher the percentage change, 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 comma, the more sensitive the variable is, and vice versa. The more sensitive the variable is, the more sensitive the variable is, and vice versa, and vice versa, and vice versa. Yeah, that's for impact. For break even, you see that the smaller the percentage change, the more sensitive the variable is. But for impact analysis, the bigger the percentage change, the more sensitive the variable is. So now let's evaluate this. And in this case, we see that under impact analysis, we need to compute the percentage change in NPV. So how do we get NPV? Is the present value of cash inflow, you raise the present value of cash outflow. A project is for 2 years. So we have the period. That is, we have year 1, year 2. Then we get the cash flows. Cash flows. Now, in this case, we have the savings, we have the running cost. So to get the savings, in this case, will represent the revenue. Then you are given the running cost. So to get the net cash flow, you take the savings minus the running cost. So we have 12,000. Here we have 14,000. Then you deduct the running cost. Year 1, we have it's 4. Year 2, we have it's 5. So here you have a net of 8, a net of 9. Then you need to discount. So present value interest factor. How much is the cost of capital? The cost of capital is 9%. Good. So give me 9% here one. Seven, 4, 8, 5, 7. Now let's get the present values. Get the present value. Sorry? This one. We have it's 8417. Now give me the present values. Sorry? 73? That's 9. 75, 70. Good. Now let's add the two to get the present value of cash inflow. You get 14. 914, Good. So objective is to get NPV. So to get NPV, you deduct the present value of cash outflow. How much was the initial cost? Yeah, initial cost we have is 10,000. So that means the net present value of the project will be 4940. Now let's carry out now sensitivity analysis. We determine how are these key factors will influence the profitability index when they are affected adversely by how much? 10%. Good. For impact analysis, they are always specific. So sensitivity analysis. So the first variable is what? To that, determine the sensitivity of the project to changes in levels of cost of plant, running cost, and saving. Those three variables. So we start with the first one, which is the cost of plant. Now, how much was the cost of the plant? 10. When it's affected adversely by 10%, this cost, will it increase, will it go down? It will increase the cost, it will increase. Therefore, that affected adversely by 10%. So you multiply by 1, 10%. So it will increase to 11,000. So how much will be our NPV? Remember, I said that at the impact analysis, we compute the percentage change in NPV. So to get NPV, you take the present value of cash inflow. That one is not changing, 14,914. Then you raise the present value of cash outflow. Now, when it's affected adversely and increased by 10%, now it will be 11,000. So our new NPV will be how much? That 940. Good. Now let's compute the percentage change. The base case NPV was 4914. Then when you change the cost of plant, the NPV reduces to that 914, you get the change. Then you divide by the base case NPV, 4914. Then you multiply by 100%. What do you get? Yes? 20.35%. Good. Now let's evaluate the other factor. The other factor was running cost. Running cost is also an outflow. So when outflow are affected adversely, you expect them to increase. How will it influence our NPV? So we have 2 years. Now we get the cash flows. So how do you get cash flow? You take the savings. Year 1 was 12. Year 2 was 14. Then you deduct the running cost. The first year it was 4. The second year was 5. But in this case, we're evaluating the running cost. When running costs are affected adversely by 10%, that means they increase by 10%. So you multiply by 110%. Also, this 5,000 you multiply by 110%. So that's 4,400. You get 76, right? And that's 5,500. You get 75. 85, eh? Good. Then we discount. Present value interest factor, 9% year N. So year 1, we have it 0.9174, 0.8417. Now let's get the present value. 69.72. Sorry? 71.54. Now let's add the two to get the present value of cash inflow. You get the 14,126. So objective is to get NPV. So to get NPV, you deduct the present value of cash outflow, of which the cost of plant was 10 million. So a new net present value will be 4126. Good. So that means if the running costs are affected adversely by 10%, NPV reduced to 4126. Now let's compute the percentage change in NPV. The base case NPV was 4914. Now has reduced to 4126. You get the change. Then you divide by the base case, which was 4914 times 100%. So how much is that? Sorry? 19.1. Zero 0.4%. Lastly, the other variable to evaluate was savings. For savings, we have the period 1, 2. Then we have the cash flows. Saving is an inflow. When inflow are affected adversely, you expect them to do what? To reduce. Good. So here we had 12,000. Here we had 14,000. If they are affected adversely by 10%, that means they reduce by 10%. So now you'll have how much? 90%. So that we get now the cash flows, I mean the savings. And then to get the cash flow, you deduct the running cost. Remember, you see that when evaluating one factor, each factor is independent, holding all the other factors constant. The running cost was 4. The running cost was 5. So what do you get? 68, eh? We have 76. Now we discount present value interest factor 9% year N. We have 0.9174, 8417. So now let's get the present value. The first one, 62, 38. Sorry? So now let's add the two to get the present value of cash inflow. 90? 6397, eh? So you get 12,635. So to get NPV, you raise the present value of cash outflow. The cost of the plant was 10. So the net present value will be 26,35. Now let's get the percentage change in NPV. So the base case NPV was 4914. Then you deduct 2635, you get the change in NPV, then you divide by the base case, 4914 times 100%. What do you get? 46.38%. So now let's go back to the required. You are to determine the sensitivity of the project to changes in the level of cost of plant, running cost, and savings, considering each factor at a time, and assuming each factor is varied adversely by 10. Number 2, comment on the factors which is the most sensitive to adverse variation. Sales, savings. So now let's make a summary. Here we had 3 variables. We have the percentage change in NPV, and then now we can comment. So we had 3 variables. The first one was cost of plant. Then we had the running cost. And then we have savings. So for the cost of plant, we have 20.35. We had 16.04%. Then we have 46.38. You'll see that for the impact analysis, they had the percentage change, the more sensitive the variable is. So savings is the most sensitive. Then this is the least sensitive, and this is the moderate. What does it mean? So if you start with the cost of plant, if the cost of plant is affected adversely by 10%, the entire profitability will reduce by 20.35. If running costs are affected adversely by 10%, the entire profitability or NPV reduced by how much? 16.04. But if saving they just decreased by 10%, the total NPV will reduce by how much? 46. So that means savings is very sensitive. A small change of 10%, risk reduction by 46.38% in NPV. So you can copy now. Now, let's look at scenario analysis. It's just a continuation of sensitivity analysis. We like to say that this is the use of horizon analysis, like this, right? Horizon. This is the use of horizon analysis to estimate stroke project, to estimate stroke project the project cash flow, project cash flows under different reinvestment rates, under different reinvestment rates. Full stop. Then right, we see that scenario analysis is more relevant than sensitivity analysis. Scenario analysis is more relevant than sensitivity analysis. Because sensitivity analysis assumes that variables are independent. Sensitivity analysis assumes that variables are independent. Full stop. However, in practice, variables are dependent, stroke interrelated. Variables are dependent, stroke interrelated. May 2012, question 3B. To that, the financial manager of Top Limited expects earning before interest and tax of 5 million in the coming financial year. The company pays interest of 10% per annum on long-term loan of 20 million. 10% per annum. So that means the interest on loan, that is 10% per annum, and they have a loan of 20 million. That means the annual interest rate is 2 million. The company has 1 million ordinary shares, and the corporate tax rate is 30%. The finance manager is currently examining 2 scenarios. Scenario 1, a case where the earning before interest and tax is 25% less than expected. Scenario 2, a case where the earning before interest and tax is 25% higher than expected. Required. Earnings per share under scenario 1 and scenario 2, and when there is no change in the expected earning before interest and tax. So scenario analysis, when there is no change, also under scenario 1, and then scenario 2. So now the question is, the requirement is earnings per share. How do we get the earnings per share? When determining the earnings per share in financial management, it will depend on the capital structure of the company. For example, in this case, we have equity because we have the number of shares. Then they have a long-term loan of 20 million. So that means they also have debt. It's debt and equity finance. So therefore it will be earning before interest and tax. Then you pay the interest so that you get the profit before tax. Then you tax at 30%. Then you get the profit after tax. Then you divide by the number of shares. In short, if you take EBIT minus interest, you get the earning before tax. Then you raise the tax, you get the profit after tax. Then once you get the profit after tax, that's the total earnings. You divide by the number of shares to get the earnings per share. So now let's start when there is no change. We need to get earnings per share. How much is the expected EBIT? We have it's 5 million. You minus the interest, which is 2. 1 minus T, it's 0.7. How many shares does the company have? 1 million. So 3 times 0.7, you get 2 points. Now let's separate now scenario 1. Scenario 1. Now scenario 1 was a case where the earning before interest and tax is 25% less than expected. 25% less than expected. So how much now will be the expected earning before interest and tax? How much is the current EBIT? 5. When it reduces by 25%, now you multiply by 75. So it will be an amount of 3 points. 3.75. Good. So now with that, now let's compute the earnings per share. So it will be earnings per share. You take the EBIT, of which is 3.75. The interest remain constant. Interest is 2. 1 minus T, 0.7. The number of shares does not change. It's 1. So how much will be the expected EBIT? 1.225. Good. So now let's compute the percentage change. So our base case earnings per share was 2.1. If the EBIT reduces by 25%, earnings per share reduced to 1.225. So get the change in earnings per share. So you minus 1.225. Then you divide by the base case, which was 2.1. Kindly stop writing. I'll give you time to write. First of all, understand. What do you get? Good. 41.67%. Now let's go to scenario 2. Now scenario 2 was A case where the earning before interest and tax is 25% higher than expected. So you expect the same change because it's increasing or reducing by the same percentage. So that means the percentage change in earnings per share will be the same. So scenario 2, a case where it's 25% higher than expected. So therefore, the expected EBIT will be 5, you multiply by 125, and you get 6.25. Good. So now let's get the earnings per share. EBIT 6.25. You deduct the interest of 2 million, then you less tax. Get profit after tax. Then you divide by the number of shares, 1 million shares. So how much is the IPS? 2.975. So now let's get the percentage change in EPS. The base case and EPS was 2.1. When the EBIT increases by 25%, also the earnings per share will increase to 2.975. So just get the change. So you take 2.975 minus the base case 2.1, or alternatively you can take 2.1 minus, but you ignore the sign. Are you together? Then you divide by the base case 2.1. See that in the sensitivity analysis you ignore the sign. You still get for 1.67. Since they're increasing and reducing with the same percentage, the effect will be the same. Good. Part 2 of the question. Degree of financial gearing for both scenario 1 and scenario 2. So we'll cover that one in another topic. That's special topics in financing. That's another new topic, leverages. So you can copy that. Let's look at the differences between scenario analysis and sensitivity analysis. Differences between sensitivity analysis and scenario analysis. Then you can prepare a schedule. One side scenario analysis, the other side sensitivity analysis. Number one, on scenario analysis side, it's that all variables are analyzed at the same time. All variables are analyzed at the same time. All variables are analyzed at the same time. On the other side, variables are analyzed separately, each at a time. Variables are analyzed separately, each at a time. Now that's what we have been doing under sensitivity analysis. You see, for example, the other question we had just done, the cost of plant, running cost, and saving, we evaluated each at a time because it assumes that variables are independent. What about in scenario analysis? Here we had three factors. One was the number of shares, EBIT, interest. But we assume that all variables are related, so we analyze them at the same. Number two, under scenario analysis side, variables are dependent, stroke related. Variables are dependent, stroke related. Variables are dependent, stroke related. Now, on the sensitivity analysis side, variables are independent. Variables are independent. Yeah, that's why you have to evaluate each at a time. Variables are independent. Another difference under scenario analysis, try to see that there is an extreme. There is an extreme end analysis. Extreme end analysis. There is an extreme end analysis, i.e., the best and the worst. The best and the worst. The best and the worst. On the other side, there is no extreme end analysis. There is no extreme end analysis. There is no extreme end analysis. Good. Those are the differences between sensitivity analysis and impact analysis. And you see that this is a very common area. So I want us to do another illustration. We do for December 2022, question 1. After our sitting. Hoping you are there by now. Now let's start with part A of the question. Part A of the question. Explain the term real option as used in capital investment appraisal. Real option. What are real options? Now, real option in financial management, there are options. Don't write. We'll come to that later. The option which gives the manager the right but not obligation to either undertake or not to undertake a project. And what are those type of real options? Real option. Number one, we have option to abandon, option to delay, to expand, lease or buy, replacement analysis or option to replace, all that. Let's go to part 2 of the question. Evaluate 3 types of real option. I've mentioned 6. So just require 3. Then you explain. Those are a total of 8 marks. Then part B, 12 marks. Now, I want us now we do part B. Part B. Part B. The management of College Publishers Limited has estimated the following initial cash outlays and the net cash flows and probabilities of the new printing process in each case scenario. You have year 1, so you have year 0. Year 0 means now. That's the present value, the amount you're investing. Year 1, year 2, year 3, year 4, year 5. Then you have 5-star. 5-star, that one represents salvage value or the terminal benefits. Then you have the probability. And the worst case scenario is 0.2. Most probable is 0.6. Best case is 0.2. Year 0 is the initial cost of the new printing process. Year 1 to year 5 are the operating net cash flows. And year 5-star is estimated salvage value. The firm cost of capital for the project of average risk is 13% per annum. Required. Assuming that the above project has an average risk, compute the expected NPV of the project. So I want to give you a chance. Can you do that question again? And then try to come up with the logic of that model. How will you be able to tackle that answer? They want NPV. Where will you start? Because you might assume that these things are very easy because I'm the one doing them. So just read it. Have 2 or 3 minutes. Read it. Then you can start even computing. I just come to correct you. No, I'll be here. Just read the question. Let me share the question paper for us sitting. Yeah, start computing. You know, you have already covered this topic. So that means you have a fresh mind. How can you answer that? You see that question number 1 has 20 marks. 20 marks. As simple as that. Why you got to brainstorm? No, this is not simulation, it's not decision tree. Hmm. You see how things are tough, eh? We have done questions on sensitivity analysis, scenario analysis, you have understood. Then the question, the same question, eh? But now that because the teacher is not the one solving, very hard. Now let's do it. Let's do it. Requirement number 1, assuming the above project as an average risk, compute the expected NPV. expected NPV. How do you get NPV? Minus the present value of cash outflow. We have how many scenarios here? We are not computing NPV, we are computing expected NPV. That means there is an element of probability somewhere. Good. Now, for example, let's start with the worst case scenario. Worst case. How much is the capital? 100. Then from year 1 to year 5, how much is the cash flow? Are they the same? So it's an annuity, right? Then at the end, you get a salvage value of how much? 5. Good. So to get the present value of cash inflow, year 1 to year 5, it's an annuity of 20,000. Present value interest factor of an annuity, the cost of capital is 13% for 5 years. Then you add the terminal benefits, which is 5. Present value interest factor. This is not an annuity. So use the first table, 13% year 5. And then at least this time, they were very lenient. They give you 13%. 11%, 13%, they are not in your table. But in this case, they had decided to give you the values. 20 million, 13% for 5 years using the annuity table. 7.2. Then you add 5,000, 13% for 5 years using now this first table. 5,428. Now give me the present value of cash inflow. All right. 70. The next one is 345, right? 73. 058. Yeah, that's the present value of cash inflow. So to get NPV, you deduct what? Present value of cash outflow. How much are you investing? 100. So that means under the worst case scenario, how much will be the net present value? You get negative 20? 940? 942. Most probable. And the most probable, to get the present value of cash inflow, year 1 to year 5, how much is the annuity? 630 for 5 years, right? So you'll take 30 times present value interest factor of an annuity, 13% for 5 years. Then we have the terminal benefit, 5-star, an amount of 20,000 present value interest factor, 13% year 5. So it will be 30, 3.5172. You add 5, sorry, not 5, but 20. 20, 13% for 5 years is 0.5428. To get 116, 372. So that's the present value of cash inflow. To get NPV, you deduct the present value of cash outflow. The capital is constant, is 100. So the net present value will be 16,370. Then lastly, under best case. Best case. So to get the present value of cash inflow, how much is the annuity? 40 for 5 years. Present value interest factor of an annuity, 13% for 5 years. How much is the terminal benefit? 30 present value interest factor, 13% year 5. So 13%, we have it's 3.5172 You have 30. 13% for 5 years is 0.5428. Mm-hmm. 156. And you have those who are copying. I gave you opportunity to write what you know. You wrote nothing. Eh? Now, instead of you reason, and then later you complain that John Mark, you are too fast. No, I'm not too fast because everything I should do explain here, right? I always explain. I've never written something without explaining. I actually repeat twice. Then someone is busy copying. Then I always maswali, you are too quick. Eh? Hey, listen so that you copy something you know. Eh? Now let's deduct the present value of cash outflow. How much were you investing? Yeah, once when you are my student, I have the responsibility. Eh? Yeah, so kindly follow my instruction. CPA can humble you, so. This thing humbles you. Eh? The net present value at base case scenario is 56. Now the question was, you determine the expected NPV. So how do we get the expected NPV? So to get the expected NPV, you take summation of NPVs times the probability of occurrence. So under worst case scenario, our NPV was negative 26,942. What's the probability of the worst case scenario? 0.2 plus, and the most probable, the net present value was 16,372. And the probability of most probable was how much? 0.6. And then lastly, 56,972. And the probability of this happening was 0. Oh, good. Now give me the expected NPV. The first one is negative, eh? What's that? Sorry? Sorry? 15.8? Let's work with that. So that's the expected NPV. Number two. A sensitivity analysis of the salvage value. A sensitivity analysis of the salvage value. If this variable changes from the base case value by plus or minus 80%. Now that's sensitivity analysis. Now the question is it break-even or impact analysis? Why impact? I didn't say you read the question again. I have just read the question. Eh? It's either increase plus or minus 80, that's all. That's impact or break even. When you go too quiet, how do you what's happening? This is impact analysis, right? We said that for impact analysis, they are specific. The variable will change by 10%. For break even, they are not specific. That's why you had to say, let this be X. Are you together? So in this case, it either increases by 80 or minus 80. But now, the percentage change will be the same, right? So that if they increase or reduce by the same percentage, the effect will be the same. Now, another question. At the impact analysis, what's the difference between break-even analysis and impact analysis? Yeah, you can be able to identify its impact analysis, but how do you solve? What do we compute? There is something I told you to underline. Can you go back to your notes? What do we say? We compute the percentage change in what? NPV. For break-even analysis, we are computing the percentage change for each variable. For example, it's sales revenue. You take the sales revenue before and after analysis. For impact analysis, we are looking at the effect to the NPV. So you have to compute the percentage change in NPV. Now let's do that. First of all, let's get the NPV. So To get the expected NPV, first of all, we get the expected capital. We also need to get expected annual cash flows. Also, we need to get the expected salvage value. Now, let's start with the expected capital. Now, this sensitivity analysis has nothing to do with that. Are you together? So, initial capital, we had 3 scenarios. So, we have to get the average. Under worst case scenario, the initial capital was 100. What was the probability? And most likely, how much was the capital? Still 100, probability of 0 point. Best? 0 point. And it still remains to be how much? 100. Also, we have the annual cash flows. Under worst case scenario, how much was expected annuity? So it was 20, 20, 20 for 5 years, right? So you take 20, and the probability is 0.2 plus, most likely, how much is the expected annuity? 30, and what's the probability of that? 0.6. Then best, 40, with probability of 0.2. That is 4. That is 18, 22. 22 you added to get that, right? Can you confirm that? It's that, right? We do the same for the expected salvage value. And the worst case scenario, how much is the expected salvage value? 5. And the probability of that happening is 0.2. And the most probable, 20, with probability of 0.2. Best, 30, with a probability of 0.2. This is 1,000. This is 12,000. And here we have an amount of 6,000. So 12, but that's 19, right? 19. But now we are conducting the sensitivity analysis to changes in what? Salvage value. Are you together? Do we use plus or minus? I just want to do one, because whether you increase or reduce by 80%, the percentage change will be the same. We should increase, eh? So increase by 80%. And it's the salvage value. So the expected salvage value now will be, the average salvage value is an amount of 19. If it increases by 80%, you multiply by 180. So how much will be that? That's for 200. Good. Now let's get NPV. And remember, I said that under impact analysis, we compute the percentage change in NPV. So we compute NPVs. To get NPV, present value of cash inflow, you do the way we did this. How much is the annual cash flows? Is there, it's that times present value interest factor of an annuity, 13% for 5 years. Then we add, we have the terminal benefit of the salvage value. How much is the salvage value? It's not there, it's here. It's an amount of? Yes, this is what we are evaluating. When it increases by 180%, now it will be an amount of 34, 200, but you need to get the present value. Present value interest factor, 13%, 5 years. So this one will be that. 13% for 5 years was 3.5172. 34, 200. Then we have 0.5428. What do you get? You are getting 124, 08, yeah? So that's the present value of cash inflow. To get NPV, that's the present value of cash outflow. The initial capital, it's 100,000. So the net present value will be 24,000. Now you can compute percentage change. NPV. So this was the base case NPV, 15,829. If the salvage value increases by 80%, NPV increases to 24,000. 8, you get the change. So you'll take 24,080, you minus 15,829. You just get the change in NPV. Then you always divide by the base case. And the base case was 15,829 times 100. You get? 52.1. So that means if the salvage value increases by 80%, total NPV will increase by 52. Is it a sensitive variable? Is it a sensitive variable? No, it's not. No. You see, an increase of 80%, profit only changes by 52. So it's not that sensitive, as opposed to the other one we did, where if the savings was affected by only 10%, then PV changed by 42%. Are you together? Yeah, so it's not that sensitive. Number 3. Number 3. Assume that all cash flows are positive, perfectly correlated, and there are only 3 possible cash flow scenarios over the time, namely worst case, most probable case, and best case. Yeah, these are the scenarios. You only have 3 scenarios: the worst case, most probable, and best case. With probability of 0.2, 0.6, and 0.2 respectively. Determine determine the project standard deviation of NPV. Determine standard deviation. How do you get the standard deviation? Standard deviation, you take returns minus expected return square probability. You add, then you get the, well, that you measure standard deviation. But in this case, we are computing in relation to NPV. So it would be summation of, instead of return now, it's NPV. Instead of expected return, it will be expected NPV square probability. You get the square root. We have 3 scenarios. These are the scenarios. And the worst case, the NPV was negative 26,942. And the most probable NPV was 16,372. And the best case, we had 56,972. You compare that against the average. The average is expected NPV. And the expected NPV was how much? Yeah, it was 158, 29, 158, 29, 158, 29. And then you square to eliminate any negative that might exist. Then the probability. What's the probability of the worst case scenario? 0.2. The other one was 0. And 0.2. Give me that. Which one? The first one is? Yes? 865. 365. 871. 688. Can you make yourself useful? Yeah. The last one? Okay, let's go to the second one. 176, 909.4. 176. Like that, 18. 3. Hii ni uongo bana. I did not get the square root. Are you together? Eh? Which one? The last one is 338. 5? Uh-huh. 29. Good. What about the second one? Sorry? The last one is 337. Aya, work on the second one. 176? 909. Good. Add the total. Three. You get 7 what? Yes? Sorry? Good. Get the square root of the answer. 540? 540. Good. As simple as that. Now let me explain something about the formula. Eh? Now let's be here. This is how the formula works. NPV minus expected NPV. You see it's in bracket. Eh? I use what we call body mass. You square. Then you multiply by what? This means what? You add all of them. That's when you get them. Now, what you what you are doing before, it's NPV minus expected NPV square probability square root. This is not the formula. Are you together? First of all, you have to add all of them before you get the square root. Good. Now you can comfortably copy. Yeah, hurry up so that we can do another illustration. I told you that this semester I'm very serious. Eh? Yes. Very serious. We do as many illustrations as possible. I want to raise the pass mark. I mean the pass rate. Yeah, from 70% to almost 99%. Yeah, this semester, that's what I want. For all my classes. Eh? Yeah. Don't say, wow, you should pass. Eh? For you to pass that rate. Eh? In advanced financial reporting, we had, I think, 85%. Yes. Yes. Advanced taxation had the highest in advanced level. Followed by advanced financial reporting, then leadership and management. And then financial management. Audit was the last one. But the good rate. Actually, advanced level, we had the highest pass rate as compared to the intermediate level. So next class, we start a new topic, that's replacement analysis.